3i Atlas was discovered on July 1st by the NASA-funded ATLAS survey.
3 Atlas was discovered on July 1st by the NASA-funded ATLAS survey. The first whispers about 3 Atlas were unsettling enough. It was only the third identified interstellar object after the famous Oumuamua and Boris. And from the moment astronomers began tracking its trajectory, they knew it wasn't like anything that originated within the solar system. The James Webb Space Telescope's latest observations have now stripped away whatever veil of mystery remained. And what they reveal is not just unusual, it's profoundly disturbing in ways few expected. What was initially thought to be an ordinary icy traveler from another star system has instead presented a series of chemical, structural, and dynamical anomalies that defy the rules we have come to rely on for planetary science. Before we start, smash the like and subscribe buttons for more updates. The data shows that 3i Atlas is not just a rogue fragment of cosmic debris. Its surface is layered in a manner inconsistent with standard comet or asteroidal bodies. Instead of a chaotic mixture of ice and rock, Webb spectrometers detected distinct repetitive bands of material, almost like geological strata carefully assembled rather than randomly accreted. These layers include exotic silicates that shouldn't have condensed in any known stellar nursery environment, alongside carbonaceous compounds of a complexity never before seen on such an object. The presence of certain polycyclic structures hints at chemistry that skirts the border between organic precursors and engineered polymers. For astronomers trained to look for randomness in nature's construction, this orderly segmentation feels ominously deliberate. Equally unsettling are the thermal signatures. Unlike a typical comet that heats unevenly when sunlight strikes it, 3i Atlas appears to regulate its surface temperature across vast regions. Webb's mid-infrared data revealed that certain areas maintained a near-constant thermal balance even as the object rotated and solar exposure shifted dramatically. This isn't the behavior of a fragile ball of ice-venting gas. It resembles thermal management, the kind one might associate with insulation, heat sinks, or some process that actively redistributes energy. While mainstream researchers hesitate to leap toward extraordinary explanations, the reality is that nothing in astrophysics comfortably accounts for such control. The orbital mechanics deepen the unease. 3i Atlas doesn't simply follow the hyperbolic path dictated by gravity alone. Its trajectory deviates in subtle but persistent ways, small enough to be ignored in early analyses, but undeniable with Webb's high-precision tracking. These deviations cannot be explained solely by the standard non-gravitational forces comets produce when jets of vapor push against their bulk. Instead, the deviations occur without detectable outgassing, suggesting forces internal to the body or influences beyond what our current understanding allows. It mirrors the same confounding accelerations that stirred debate around Oumuamua years ago, but now magnified with clearer evidence. What unsettles the scientific community most is the timing of these anomalies. They are not random spikes, but recurring patterns, almost as if they are part of a cycle. Webb observed shifts in brightness, thermal output, and spectral lines that repeat on intervals too neat to be mere coincidence. These periodicities evoke the image of a mechanism, something ticking away inside 3i Atlas on a schedule that doesn't align with natural processes. Each recurrence strengthens the suspicion that we are not simply studying a frozen relic from a distant star system, but something that once had, or still has, an organized internal function. Chemically, the truth becomes more unsettling. With every line of data, among the compounds detected are isotopic ratios wildly out of step with what stellar evolution would predict. Certain heavy isotopes appear in excess while others are absent altogether, breaking the expected fingerprint of cosmic formation. Such discrepancies suggest one of two uncomfortable possibilities. Either 3i Atlas formed in an environment alien to anything in our galactic models, or it underwent processes of refinement that sorted materials unnaturally. The former would force a rewriting of astrophysical textbooks. The latter veers toward implications most scientists would rather avoid speaking aloud. The scale of 3I Atlas only magnifies the tension. This isn't a small fragment like it is larger, denser, and far more massive than initial estimates indicated. Webb's refined measurements of its albedo and density reveal an object with a mass of a substantial asteroid, but with a hollow-like internal structure, suggested by its gravitational influence on dust and gas in its vicinity. A body that size, carrying echoes of hollowing, layered construction, and controlled thermodynamics, paints a picture that looks alarmingly closer to architecture than geology. The implications for planetary defense are equally grim. If such objects can slip into our solar system undetected until they are already on an outbound or inbound trajectory, then our models of space hazard management are woefully inadequate. 3I Atlas is not on a collision course, but the possibility that similar bodies exist, some perhaps less forgiving in their path, introduces a new category of existential risk. The difficulty isn't just in predicting their arrival, but in not knowing whether they behave under the same rules of physics we depend on for tracking. If an interstellar object carries its own internal dynamics or propulsion-like anomalies, traditional orbital projections become unreliable. Beyond the danger, there's the philosophical weight. Humanity has long wrestled with the idea that the cosmos may carry other intelligences, but rarely has observational astronomy forced the question so bluntly. The Webb data doesn't shout answers, it whispers puzzles that look uncomfortably like intentional design. If 3I Atlas is natural, then nature is far stranger and more capable of structured complexity than we imagined. If it is artificial, then we are staring at the ruins or perhaps the dormant husk of something born in a star system we may never identify. Both options expand the scope of the universe into realms that challenge human imagination. The absence of clear aftermath does not soften the blow. The event itself, receiving hard data from the most powerful telescope humanity has ever built, has already shifted the axis of thought. Astronomers who once dismissed whispers of alien probe theories are now forced to acknowledge that whatever 3I Atlas is, it is not comfortably explainable within current paradigms. Cosmologists and physicists alike are scrambling to frame hypotheses. Yet, each hypothesis opens more disking questions than it resolves. The scientific method thrives on anomalies, but this anomaly feels less like a puzzle piece and more like a tear in the puzzle itself. The truth that Webb has handed down is worse than expected, precisely because it resists assimilation into the familiar. We anticipated learning more about how interstellar comets form, about the building blocks of other star systems, maybe even about the diversity of cosmic chemistry. Instead, we are confronted with an object that erodes the boundary between natural and unnatural, between random formation and purposeful construction. The danger isn't just in what 3I Atlas might physically represent, it's in what it does to our frameworks of understanding. If one such body exists, how many more wander the void? If they are natural, why are they so rare? And what exotic processes give rise to them? If they are not, then what is their origin? And are they truly abandoned? Every line of Webb spectral data, every plotted deviation in its orbit, every repeating pulse in its thermal emissions tightens the knot. The implications echo far beyond astronomy into questions of philosophy, theology, security, and even identity. To gaze at 3I Atlas now is to realize that the universe may not only be stranger than we imagine, but stranger than we can remain comfortable imagining. The truth revealed is not a tidy discovery tucked neatly into textbooks, but an open door to a darker, wider reality, one where the unknown stares back at us with a complexity we can scarcely begin to fathom. The revelation about 3I Atlas from the James Webb Space Telescope marks a turning point not just for astronomy, but for the collective human imagination. The data that poured in after Webb locked its instruments onto the object dismantled every tidy category we had created for interstellar visitors. If Oumuamua was the first whisper that our cosmic neighborhood might be more complex than we realized, 3I Atlas is a thunderclap shaking the foundations of planetary science. What makes it so disturbing is not merely that it is strange, but that its strangeness is layered, deliberate, and resistant to the kinds of explanations that normally tame anomalies. Webb's imaging spectrograph went further, revealing that those reflective zones are not randomly distributed. They are aligned with remarkable consistency, forming geometrically suggestive streaks that span kilometers in near-perfect parallel. On Earth, such alignments conjure the fingerprints of engineering, though astrophysicists are careful to restrain such language. Still, there is no precedent for an interstellar object with such organized external patterning. The likelihood that an entirely natural process generated both the composition and alignment of those reflective streaks stretches probability to the breaking point. When astronomers began modeling its interior based on density and gravitational behavior, matters grew even more alarming. Even massive, well-studied asteroids within our solar system exhibit tumbling motions from past impacts. Yet here is an object traveling light years through the void that remains poised like a perfectly balanced gyroscope. Such stability invites speculation that goes far beyond natural formation. The chemical composition has thrown its own set of unsettling challenges into the mix. Webb spectrographs picked up spectral signatures resembling fluorinated carbon compounds, substances rare in nature but common in synthetic materials used for resistance to extreme environments. These signatures cannot be casually brushed aside as coincidence. If confirmed, they would indicate chemical processes alien to standard stellar chemistry. The discovery unsettles not because we lack models of exotic chemistry, but because the detected compounds bear uncanny similarity to industrial materials that humanity itself engineers. The parallel is difficult to ignore, even if scientists refuse to draw the line explicitly. Adding to this eerie tableau is the way 3I Atlas interacts with its environment. Dust particles near its path behave oddly, clinging longer than expected before scattering. Some appear to deflect at consistent angles, as though encountering a structured electromagnetic field. Webb's instruments are not optimized for magnetic detection, yet the data implies there may be field-like interactions shaping the dust distribution. Interstellar objects usually plow through the medium indifferently, their gravity and occasional gas jets dictating the choreography of surrounding particles. Here, however, is evidence of a hidden influence, as though the object carries a sheath or aura that shields and redirects. Whether natural plasma interactions or something more complex, this is another anomaly stacked atop a growing tower. The light curves provide perhaps the most chilling evidence of all. Normally, as rotating bodies move, their brightness fluctuates irregularly depending on surface shape and albedo. But in the case of 3I Atlas, Webb recorded brightness variations that followed repeating cycles, nearly harmonic in their recurrence. These cycles persisted even after accounting for rotation and geometry, implying a source of modulation beyond mere reflection. To describe it plainly, the object appears to pulse, not in the radio sense of a pulsar, but in visible and infrared light. These pulses repeat in precise intervals, and although no clear signal has been identified, the very existence of periodic output from a supposedly inert body is profoundly disturbing. This level of strangeness demands comparison to earlier interstellar objects. Oumuamua confounded astronomers with its odd acceleration and elongated shape, sparking debates that still rage years later. Borisov, by contrast, behaved like a textbook comet, reassuring scientists that at least some interstellar wanderers fit into familiar molds. 3I Atlas obliterates that comfort. Where Oumuamua provided ambiguity, 3I Atlas provides data. Hard numbers from the most advanced telescope in history that cannot be dismissed as mere misinterpretation. The object is larger, more complex, and more orderly than either of its predecessors, leaving far less room for benign explanation. The scale of what this means reverberates beyond astronomy. For planetary defense experts, the unsettling prospect is that such objects might not be rare at all. If others like 3I Atlas exist and wander the galaxy, they represent an unpredictable category of visitor, larger than comets, stranger than asteroids, and resistant to the models we use for predicting orbits. One grim implication is that if even one such body were on a trajectory toward Earth, we might not understand its movement well enough to mount a defense. Traditional mitigation strategies depend on predictable physics, nudging or deflecting an object with known mass and momentum. But what if the object contains unknown dynamics, self-regulating mechanisms, or hollow structures that respond unpredictably to impacts? In such a case, our planetary protection plans collapse. There is also the matter of galactic origin. If the isotopic anomalies are to be trusted, then 3I Atlas does not resemble bodies formed in any local stellar nursery we know. Its isotopes speak of an environment outside the metallicity norms of the Milky Way's arms. That suggests either it is extraordinarily ancient, dating back to a time when the galaxy's chemistry was radically different, or it hails from a region with peculiar astrophysical processes. In either scenario, we are peering at matter that carries a different galactic history embedded in its structure. It's not just an interstellar visitor, it is a messenger from an epoch or location where physics produced outcomes foreign to us. Another haunting aspect lies in its silence. Unlike pulsars, quasars, or even cometary jets, 3A Atlas does not scream across the spectrum with obvious emissions. Instead, it whispers with subtle modulations and faint signals that require Webb sensitivity to detect. This quietness is almost more troubling than noise because it leaves open the possibility that we are missing layers of data outside Webb's bandpass. Instruments tuned to radio or high-energy photons might one day reveal a different side to this object. But until then, we live in a suspended state of ignorance, aware of its strangeness, but blind to the full extent. The scientific community's unease stems from the collision of two fears: the fear of the unknown and the fear of recognizing the familiar in an alien context. On one hand, 3I Atlas could be a natural phenomenon that stretches our physics beyond recognition, forcing us to rewrite entire sections of planetary science. On the other hand, it could represent something that is not entirely natural, in which case the implications spiral into territory humanity has never seriously prepared to face. The first possibility threatens intellectual comfort. The second threatens existential comfort. The object's motion out of the solar system adds urgency to the mystery. Like Eumuum Imua, it will not linger for long. Each observation window Webb secures becomes precious. Yet, the more data we gather, the more questions multiply. In the coming years, as 3I Atlas fades into the void, the record it leaves behind will be a dossier of riddles with no easy answers. Humanity is left watching an enigma recede, powerless to chase or probe it with missions fast enough to intercept. That sense of helplessness is perhaps the most haunting truth of all. The realization that the universe can place puzzles before us and snatch them away before we are ready to solve them. The data also raises difficult questions about how humanity communicates. Discoveries of this nature, the choice to release Webb's findings in unfiltered form, ensures transparency. But it also means the broader public now confronts anomalies without a prepared framework. The result is an uneasy mixture of awe, fascination, and dread. Scientific caution insists on restraint, but the raw strangeness of the data inevitably fuels darker interpretations in the public imagination. In this sense, the event is not just about astrophysics, but about the sociology of discovery, how a civilization metabolizes truths that do not fit its expectations. Looking ahead, 3I Atlas may come to symbolize the threshold of a new era in astronomy. With Webb's instruments trained on the skies for the next decade, more interstellar bodies are likely to be discovered. If they prove as bizarre as this one, we will face the task of expanding our models, not just to accommodate diversity, but to confront the possibility that we are not alone in shaping matter at cosmic scales. If, however, 3I Atlas remains unique, it will stand as a solitary monument to the unknown, a singular reminder that the universe occasionally drops anomalies into our backyard without explanation. The unsettling truth is that we may never know what 3I Atlas truly is. The telescope's revelations have already exceeded the boundaries of comfort, pushing our knowledge to the edge of speculation. Every detail, from its reflective patterns to its isotopic ratios, suggests a complexity that outpaces our categories. What Webb has shown us is not merely an object, but a mirror reflecting back the limits of human comprehension. whether natural or artificial, benign or ominous. 3i Atlas embodies the worst-case scenario for human expectations. Not destruction, not salvation, but uncertainty on a scale too vast to resolve. And so the story of 3i Atlas lingers as an open wound in our understanding of the cosmos. The James Webb Space Telescope, designed to illuminate the universe's oldest galaxies, has instead revealed a riddle passing through our own celestial neighborhood. The event itself, stripped of aftermath, remains a snapshot of bewilderment frozen in time. An encounter with something we cannot name, cannot categorize, and cannot chase. The truth it carries is heavier than any disaster movie scenario because it is not dramatic, but disorienting. It shows us a universe that is not just vast, but deeply, unsettlingly strange. A universe that resists every attempt to make it familiar. The new revelations about 3i Atlas are not simply strange, they are transformative. Each dataset Webb has returned has added another piece to a puzzle that no one on Earth was prepared to solve. What makes this moment particularly remarkable is that 3i Atlas forces us to confront not just astronomy, but the very assumptions we hold about what it means to study the universe.